This video looks at how the gradient of a line will link to the angle that the line itself makes with the positive direction of the x-axis. That's from the origin out to the right hand side. Now it kind of makes sense that if we draw a line and make it longer and longer and longer, it will eventually meet the x-axis. At least most of them do. The only ones that don't are lines that are horizontal. Here we've got two general points. If we extend that line past those 2 points, you can see that at the bottom left of the line it cuts the x-axis. The important thing is that at this point here and this point here, the line has the same gradient. It's just an extension of the line, so the angle in the triangle is going to be the same as the angle outside the triangle, just on the x-axis. Now what we've done before is we've used the gradient formula y2 minus y1 over x2 minus x1, and that gives us the formula for our gradient. So that's the general form using point 1 and point 2. What we can also do is use the idea of trigonometry using SOHCAHTOA. If we know that the angle in the triangle is theta, that's what we call that symbol, then tan theta is the opposite side divided by the adjacent side. Now we've already established that the opposite side is y2 minus y1, the distance in the y direction, and the adjacent side is x2 minus x1. So it's equal to the same thing. In that case, what we can do is link the gradient m with the tan of the angle. So m equals tan theta. It works the other way as well. Tan theta is also equal to m. Now in a question like this, we've got 2 points given to us. What we'll have to do is work out the gradient and then decide, or then calculate what the angle is going to be. So, first things first, MAB is going to be equal to, let's see, it's going to be minus 1 minus 8, that is a 1, get rid of that, over, don't do this at home kids, 5 minus 9, so that's minus 9 over minus 4, which works out as 9 over 4. Now that means that tan theta, tan of the angle, is 9 over 4. What we'll have to do now is solve a trig equation, very easy one. So we say theta is tan to the minus 1 of 9 over 4, which is, oh, wait for it, tan to the minus 1, 9 over 4, 66.0 degrees. Ta-da! Yay! Next! This is the same kind of example, although we have it in a different form. 5x plus 7y equals 8. So what we need is y equals, that means that 7y equals minus 5x plus 8. Divide by 7 all the way through, so we get minus 5/7 x plus 8 over 7. Now the important thing is this gradient here, m equals minus 5 over 7. Now if we have a negative gradient, we're working out 180 minus tan to the minus 1 of 5/7. So I'll just go through that very quickly. So if we work out tan to the minus 1 of 5/7, that's going to be 5 divided by 7 equals tan to the minus 1, 35.5 degrees. So theta is 180 minus 35.5. If you think about it, if we've got two axes, the gradient is negative, it's going to come down like this. So the angle here, which it makes with the positive direction, is going to be obtuse, more than 90 degrees. Okay, so 180 minus 35.5 is 144.5 degrees. Nice and neat as usual. Right, next one. Now, if you've done what you've been told and watched the video on, what's it called, the exact values, you will know that the gradient, m, equals tan theta. In this case, it's tan 30. You should know what tan 30 is, and even if you don't, you will. This is one of these exact values, 1 over root 3. That is the gradient of that line. Right, here endeth the lesson. The next questions you're to do are on page 300 of the textbook, exercise 13D. Have fun! Bye now!